Ever wondered how maps work in programming? Well, let's dive in and explore this fascinating concept. In the realm of programming, a map isn't a geographic representation of a place. It's actually a data structure, an ingenious one at that, which stores information in key value pairs. Imagine a treasure chest, but instead of gold and jewels, it's filled with pairs of keys and their corresponding treasures or values. The beauty of maps lies in their simplicity and efficiency. They allow you to store values and then retrieve these values with ease, all based on a key. Think of it as your personal coding assistant. You give it a key, a unique identifier, and it promptly hands you the associated value. It's like magic, but it's not. It's the power of maps in programming. So, you might be thinking, why should one use maps in programming? Why should one use maps in programming? Good question. You see, maps are a little like the secret superpower of data structures. They're simple, but oh so mighty. They allow us to store data in key value pairs, making our data much easier to manage and manipulate. Imagine you're in a bustling city center, and you're tasked with finding a tiny, obscure cafe. Without a map, you'd be left wandering aimlessly, wouldn't you? But with a map in your hands, you can pinpoint the cafe's location in an instant. That's what maps do in the world of programming. They provide quick and efficient access to data, saving you from the chaos of aimless data searching. But that's not all. Maps also have a knack for counting occurrences of an object. Let's say you're running a bookstore and you want to keep track of how many times a particular book has been sold. A map can easily help you tally up those numbers. Just use the book title as your key and the number of sales as your value. Each time a sale is made, simply increment the value. It's as easy as pie. Now let's talk about flexibility. In a map, the keys are not restricted to just numbers or strings, as with some other data structures. You can use any type you like, even objects. This gives you an incredible amount of flexibility when organizing your data. And here's the icing on the cake. Maps maintain their insertion order. This means that when you iterate over the elements of a map, they will be returned in the order they were added. This can be incredibly useful when the sequence of data matters. So to sum up, maps are like the Swiss Army knife of data structures. They're versatile, efficient, and can make your life as a programmer a whole lot easier. Now that we know why to use maps, we need to understand how to implement them in programming. How does one implement maps in programming? Let's dive in. In the realm of programming, the process of creating a map, adding elements, and accessing them is fairly straightforward. Let's take JavaScript as an example. In JavaScript, a map is an instance of the map object. You can create a new map by using the keyword followed by. This gives you an empty map, ready and waiting to be populated with key value pairs. Adding elements to a map is as simple as calling the method on your map. The method takes two parameters, the key and the value. Suppose we have a map called Books, and we want to add a book with the title as the key and the author as the value. We could do this by writing. This would add the book to our map. Accessing elements in a map is done using the method. If we wanted to retrieve the author of To Kill a Mockingbird from our Books map, we'd write. This would return Harper Lee. What if you want to check if a certain key exists in your map? This is where the method comes into play. The method returns a Boolean indicating whether the map contains a certain key. If we wanted to check if our Books map contains To Kill a Mockingbird, we'd write. This would return true. Deleting elements from a map is achieved using the method. The method removes a key value pair from the map based on the key. If we wanted to remove To Kill a Mockingbird from our Books map, we'd write. Now, let's talk about iteration. Iterating over a map in JavaScript can be done in a few ways. You can use the method to apply a function to each key value pair in the map. Alternatively, you can use the loop in conjunction with the method to get an array of all the key value pairs in the map. Each of these methods has its own use case and can come in handy in different scenarios. For instance, the method is great when you want to apply a function to each element in the map, while the loop is better suited for situations where you need to break out of the loop at some point. Maps are indeed handy, aren't they? But what about when you need to map a key to multiple values? Sometimes you need to map a key to multiple values. Enter multimaps. Multimaps, as the name suggests, are a variant of maps. They are a data structure that allows a key to be associated with multiple values instead of just one. This might sound a bit confusing, but let's break it down. Imagine you're organizing a music festival, and you're storing the list of bands playing each day in a map. The festival lasts for 3 days, so you have 3 keys. day 1, day 2, and day 3. However, each day multiple bands will be playing. If you were using a regular map, you'd only be able to associate each day with one band, but that's not what you want. You want each day or key to be associated with multiple bands or values. This is where multi-maps come in. So in a multi-map, each key doesn't just map to a single value, it maps to a set of values. In our music festival example, day 1 wouldn't map to a single band, but to a set of bands. You could add, remove, or iterate over the bands playing each day just as easily as if you were manipulating a single value. Multi-maps can be incredibly useful in a variety of situations. Whenever you need to represent a one-to-many relationship in your data, a multi-map can be a powerful tool. They're used in databases to represent relationships between tables, in graph theory to represent connections between nodes, and in many other scenarios. Just like maps, they provide a simple and intuitive way to manage complex data structures. So if you ever find yourself needing to map a single key to multiple values, remember the multi-map. It's a versatile tool that can make your life as a programmer a lot easier. With maps and multi-maps, you're well equipped to handle complex data structures. But how about we summarize what we've learned? Let's take a moment to recap what we've learned today. We kicked off our discussion with an introduction to maps. These are not your traditional geographical maps, but rather they are data structures that store key value pairs. In simple terms, maps are like dictionaries where you look up a word, the key, to find its definition, the value. We then delved into why we use maps. The strength of maps lies in their ability to store and retrieve data based on a key, making them incredibly efficient. They are handy in scenarios where you need to associate values with keys and retrieve them promptly. For instance, consider a phone book where names are keys and phone numbers are values. From there, we transitioned to implementing maps. We took JavaScript as an example and looked at how the map object can be used to store and retrieve data. It's not rocket science, but it does require a keen understanding of JavaScript's syntax and operations. We also touched on the concept of multi-maps. A multi-map is a type of map that allows multiple values to be associated with a single key. Imagine a scenario where you have one key, say a movie title, that is associated with multiple values, like actors in that movie. That's where multi-maps come in handy. And there you have it, a deep dive into maps in programming. Remember, mastering these concepts is a great step towards becoming a proficient programmer.